Hey nerds, well, this is live from the battlefield. I thought I'd bring you in while I'm programming this thing. And I'll let you see some of the worst code I've written in my life. As you can tell, the Chinese delivered, and there's the display I want to use for Richard's YouTube subscriber counter. And I spent a good amount of time, about 2 hours, to get this thing working. And the library that I'm using here didn't really help. Well, it does what it should, but it's heck of a complicated mess. Well, you can tell by now there's a 5-second delay that displays the LER logo over there. Well, the logo is, it's a LER letter thing. And then the counter updates. Currently, this is interlocked, so the animation blocks the counter from counting up. So I have to find a way to do this so the animation doesn't block the rest of the software. In the demo code, everything is blocking. Very, very strange written. There's so much C in there. Something simple like a non-blocking code isn't done. Don't get me started. Anyways, let's jump into the code and I show you some of the garbled mess I'm working right now on. As I mentioned before, this is not the usual, I have a project here, this is finished, let's look at the code and there's a project. This is a work in progress, so bear with me on this one. Let me know if you like this more or if you want to see finished projects that are already done and where you simply can follow the flow. And this is more a thing where I tell you guys what I was thinking, why I was programming this. First, two important links. There's one of the documentation of the class for the Parola library. I have no idea what Parola means, but it's the name of the library. So this is the one we're using, and this is a documentation. What helped me more is a video by Ralph. Ralph Bacon is a British guy, and if anything is done with an Arduino, Ralph has probably done it. If you don't know his videos, I'll link them in the description. Check him out. He's done really, really great stuff with Arduinos. So this video helped me more than all the documentation because it showed me some things I never would have come across. For the little ESP8266, there are some defined pins because we use SPI in here. So you can't change these. If you want to build this, these are your pins. No way around this. Currently, I'm using zones. You saw the display, this is an 8x2 display. So the upper row, this is zone 0, uses the first 8 displays, 0 to 7, and the second row, 8 to 15, uses the other 8. Not sure if I keep it this way, but currently this is a way to go for me. The 2 in the begin state over here actually means how many zones are there. So this means we're working with 2 zones. You have to declare this here, I think, because this has to be done in begin. The only thing my current test code is running is the do the display function over here, and it has an interval, so you guessed it right, there is an asynchronous part in here. To do the animations of the display needs to be constantly updated. This p-display animate does this, and it does this while the zones aren't done yet. So this is a request for, are the zones ready? Is there anything to animate left? And while not, we'll simply do the animate and return out there. This is because the counter didn't update while the LER is doing a thing over there. Here's the classic that does asynchronous stuff thing. The interval over here is set to 50 milliseconds as a default if I don't give it a parameter. So this is a way to do this. Every 50 milliseconds it's normally started, and then it does this. Yeah, there you were and thought, well, this is probably easy. You simply said print and it does stuff. If you want to see a good implementation, go to the U8G2 library for OLED displays. This is a really good implementation. This is, well, maybe not optimal. What I'm doing here, I have a counter, some effing counter here. Then I have a char buffer, and then I put the counter into the char buffer with the SN_print. I mentioned Ralph before. He did a great video about all the print stuff you have in your ESP32, ESP8266. If you want to read up on this, there's a way to go. Doing the same over here, and you probably see the static over here. The static is needed because the animate thing of the display needs the buffer, and if I don't do static over here, the buffer gets erased after the function is finished, and yeah, this is way not optimized right now. I'm working on it. Bear with me. And yeah, I have no idea why I can set the text scrolling effect over here and then set another text scrolling effect over here. This doesn't make sense to me. Well, maybe if I worked longer with the library, it would make sense. Currently, it doesn't. So this is my current mess, and I'm going to work on this right now, and I'll bring you in when I have more to show. Just to let you know that not everything works as it should with me. Here's a little snapshot of a moment in time where I'm really, really fed up with the code. As you can tell, the numbers are working fine, but there's a short flash in the upper segment. You saw that? This is where the LER should be now, and it isn't. And yeah, once more into the breach, we find this. Yeah, disco lightning. I'm so miffed. Well, okay, forget the fancy animations. This looks like it's working, so I have a working state. We don't have animation there, sorry Richard, but I have a working counter. This is all that matters right now. By the way, if you're wondering why the LED is so bad readable, this is because the sun is coming out right now, and I have the LEDs dimmed down to level 1 and 2, I think. So in real life, this is pretty readable. The little camera simply can't handle it. Heck yeah. Well, I know this is childish and stuff, but it needed to be done. Now I think I have something that I can work with. This isn't beautiful, but it's probably usable, and at this point I take usable anytime. So I moved my static char arrays out of the functions and made them global. This is the easier way, and and for this function, this will work fine. I split the update part from the draw part, so now I can update the upper string. Its default is LER, of course, and I can update the lower string. The number is 0 as a default. The draw upper and draw lower are asynchronous. They called in the loop all the time, and the update display only takes care of all the drawing stuff. So I guess we're fine with that. I hope. I really hope. The one thing I do in setup is I update the upper part. This is where the dead rules comes in. And the loop right now updates the lower part with milli divides by 100. So I have a continuous number over there. Then it draws the upper, then it draws the lower, and then it updates the display. This seems like a solution I can live with. So, as I said, right now I take working every time. So let's beautify this whole mess a bit and move it into a H file. This is code I can live with. I have an include which contains all the nitty-gritty stuff, and in the setup I do the init, that does all the initializing stuff. Then I do the update upper with a chosen text, whatever you like. And in the loop I do the update lower, so this is a counter, will be the number of subscribers with which it's channel. Then I draw the upper, then I draw the lower with a 10 milliseconds update interval. I don't need this fast. I could go really, really slow on this one. I probably will, and trigger this at a different speed when we have something to update, because it doesn't have to run all the time. And this update display is pretty much the update for everything, and this only takes up CPU time when it's needed. So I could live with that. Let's include it into the main software. I have to do some Wi-Fi manager there. I have to do some EEPROM there. I probably do this off camera because I probably copy a lot of them from projects I did before, and I bring you back in when I have something to show you guys. Yes, it works. Have a look at this. There's my YouTube subscriber counter, and I can log in now. Let's try and see if this works. Very good, very good. YouTube subscriber counter config, very nice. And there's my Yes, this is what I wanted. I have a channel name, I have an API key, and I have a channel ID that I could put in with the Wi-Fi credentials over here. So this is my way to get the channel name, the API key, and the channel ID into the system without having to hard code them somewhere. I think this will work. No, where's freaking name gone? I hate my life. I don't believe it. Where's the freaking ID gone? It should be somewhere in the EEPROM here. Maybe I should move to Uruguay. Become a baker or... Oh, wait. It worked. Okay, I have no idea why it worked. That's bad, but it worked. Let's see if the construction survives a reset. Looking good. I think I freaking have it. In the Wi-Fi manager routine, I called the update for the structure all the time. And of course, if it runs and you have no data to write in there, it simply overwrites everything. And this is what probably happened there and killed my stride. Yeah, and I think let's keep an eye on this. Don't be too eager, but this feels good. Yeah. Heck yeah, I think that's it. I have a counter over here. It survives the reset. It remembers the settings. Well, it has everything I wanted to have. Well, maybe I'm missing out on a few bells and whistles, but believe me, I'm done for the day, and I'm done for this project. These were two libraries that I didn't really like. Both of them didn't like me. And yeah, I'm happy that I had this going and this works right now. So I won't mess around with it. And yeah, I do a very, very short swing by with you in the software. I showed you most of it already. I'm going in for what I didn't show and what I did at last. And you can tell this is late at night because I am waving around this little flashlight over here to get some light over there. And yeah, let's go into software. This is easier to film. A few things to point out over here for the software. At first, we need an EEPROM over here because we need to store somewhere the name of the channel name. We need to store somewhere the channel ID, and we need to store the API key. So this will all go into EEPROM. And while I'm on it, I store the last count, the last active count I saw in the EEPROM too. I don't do this all the time. Only when the number changes, I store the actual number into EEPROM. This is something to avoid var leveling here in the EEPROM because it's flash. This isn't a EEPROM. This is simply flash. So this will wear out. So I try to lessen the strain on the flash step in here. Of course, I use Wi-Fi Manager to get all the parameters. You saw the image where I had my phone in my hand and was playing around with this. Wi-Fi Manager is over here in its own tab. And if you don't have a clue how this is done with Wi-Fi Manager and adding parameters in here, this is how you add the three channel name, API key, and channel ID, how you add them. When Wi-Fi Manager is done, it delivers them back. You get a channel name get value function here that drops this into a C array. And as you can tell, the C array is my structure from the beginning. This is the structure. Oh yeah, I did bad here. I used S as the structure name. So channel name is S dot channel name something something. Yeah, I know. I'm always telling you guys, use self-descripting names. If I had time and would like to do this, I would rewrite this and use a really good name for this. I couldn't come up with one, so I used S for structure. Well, it's somewhat self-explaining. Maybe not. Okay, continuing here with the show. Smart debug is my way to do all the debug stuff. Maybe do a video of this in the future. I did a German one for this. You maybe see some stuff like here, like dinit and ddelay, and do I have dprint somewhere? Of course not. It's the usual. This is my way to do the debug here. If you don't want to have debug output, just simply comment this out and you don't get any debug outputs. I like to leave it in here. We have the serial report on anyways, and it doesn't hurt, and you have debug output if you want to have it. As usual, I include a lot of stuff. So EEPROM, display, Wi-Fi manager, double reset stuff. If you press a reset button twice inside of 10 seconds, the device recognizes this, clears all settings and starts fresh. So Wi-Fi settings are gone, all the API and channel name settings are gone. This is the way to do the reset hard on here. You can do a normal reset if you need to reset the thing from any reasons. But if you want to clear all the settings, press reset twice inside of 10 seconds and all the settings are gone. The setup looks pretty much like a setup when I write a setup. So I have some inits here over here. I load my settings from EEPROM very early after I initialize EEPROM. Don't forget the initialize EEPROM. Yeah, this can take half an hour to regularize, yet you forgot initialize the EEPROM. Been there, didn't like it. Wi-Fi manager init, there's a double reset check, and then we go right into the draw stuff over here. When we, at this point, all the interesting parts for the draw thing, so the channel name and the last count, should be set. At this point, we didn't read YouTube. We haven't checked what YouTube has a current number, but we're already drawing the display. We can do this because EEPROM says the last count, the last number, and how many subscribers are in here. I did want to have this in here to have a fast start. Maybe you get a number there, and if it has been offline for a long time, you get a really big uprise here. I wanted to have this in here to have a fast start. I didn't want to sit around and wait for, 30 seconds, something, to get this going. And this is a way to do this. We simply use the last known number of subscribers in here. After that, we initialize Wi-Fi and we initialize the YouTube stuff. The loop itself is, again, as always, pretty boring. We have a loop for the double reset detector, DRD. Then we have a YouTube debug stats. Yeah, I didn't change the name of the function. This is something that is really, really old. This was one of the first functions I wrote, and I should have changed the function name. Again, code cleanup. I don't do this on this one because I already hate the software. And there's my asynchronous display, update display. Things worthy of note. EEPROM has some really interesting ways to do this. In EEPROM, I have save settings and load settings, and I have somewhere init. Of course, I have init in here. Init doesn't do a lot because it simply initializes the EEPROM at the size of the structure. You remember, S is the structure, +2. +2 is my self-made checksum over here. I normally put the 2 bytes in here that reads 1968. And now you can guess at what year I was born. If it isn't in there, I know I haven't saved my settings over here. I think get and put does this anyway. I have to check some inside there. This is my way to check if the EEPROM is really set. Here's why I put all my settings into the structure. If I want to load the settings, I simply say EEPROM get to, this is the address where it starts, and then the structure name, S. This is everything. You don't have to fight around with, what do I need to save? Do I need to save this? Do I need to save that? If your structure expands, this is bulletproof. It simply works until you run out of space in your EEPROM, of course. When I load settings, I do a little debug, what I have loaded. Yeah, and you can tell currently the API key gives you back, I'm no snitch, or the ID get your own ID. If you want to have those dumped on your debug, you simply uncomment these ones here over here, and you get the real values that you have put into the EEPROM. Same goes for save settings. I'm a bit cautious over here I clear the EEPROM before I do anything. Simply write zeros to it. Then I put my 1968 in there, and then I go EEPROM put, and this saves the whole structure. Nothing more. Don't forget, please don't forget, EEPROM commit after you save anything. You have to do this because all this stuff is saved temporary and is only saved when you go for EEPROM commit. After this, the EEPROM is really written. The already crappy display functions have changed a lot in the time between, so this works. It isn't beautiful, it is horrible, and if you like to improve on those, please be my guest. I had enough of these displays, really. I don't like them. I will go back to my OLED displays or play around with an Axion display next time. I think this is way more interesting than to do this very strange way how this is constructed here. So there you have it. This is a YouTube subscriber counter. It feels a bit Frankenstein, this whole project, cobbled together from libraries I don't like, libraries doesn't like me, and yeah, it works. Let's keep it this way. Well, we probably do a little video when we get this thing over to Richard's place and install it over there, and yeah, I'll probably bring you guys in for that. As always, I hope you learned something today. Let me know what you think of all the crazy stuff that I did over here. Let me know about the format I'm trying here, because I'm still trying to fine-tune how I do my videos, and some input would be really, really nice, you guys. Okay, have a good one, and as always, keep hacking. Well, there's a reason why I shouldn't make videos in the middle of the night without thinking what I'm showing them. I totally forgot to show you guys how the hardware is connected here. So I showed you this one, and yeah, you can see it's 276 now because someone subscribed last night. Thank you very much. But I never turned the thing around and showed you how I did the hardware. So let me fix this. So fitting to the horrible code I wrote, this is a horrible hardware I did. The PCB, as you see it over here, has a big ground plane, so I wasn't worried about the ground plane here, but I wasn't sure if the VCC would be fine. So this is a red wire you see here going right across the board and supporting the VCC on the other side. I haven't tried the circuit before, so maybe this is unnecessary, but I did it anyway. The yellow wire you see over there is the data out from the upper left corner to the lower right corner. Yeah, you have to move this over there because otherwise you have a connection between the two rows. There's the ESP8266 mounted on a WEMOS D1 board. I chose this one because there are pads and I simply can connect everything with a lot of wires, so this wasn't that hard. This is the same connection as stated in the source code. There you can see which pin goes to where. And if you want to copy this, this is the way to go. And as mentioned in the first part of the video, I skipped the fuse and the diode over here. You see the big solder blobs in the middle of the screen. I will probably get away without doing that, but I didn't want to risk blowing the fuse with a current higher than 500 milliamps. This is my solution and I stand to it. And while I was panicking about current consumption, well, the whole shebang right now draws about 300 milliamps. So this would have worked without any modification on the WEMOS D1. So you're pretty much safe if you choose the same settings as I did. So now I'm done for real. Thank you for watching, and as always, keep hacking.